Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. ABCD is a rectangle with area A. P is the midpoint of AD. The straight line joining P to vertex B and the diagonal AC meet each other at point Q. What is the area of quadrilateral DPQC in terms of A? This is an interesting geometry problem that I came across recently, and it can be solved using similarity of triangles. In the figure, if you consider the triangles AQP and BQC, consider the angles QBC of triangle BQC and APQ, angle APQ of triangle APQ. So those two angles are marked in blue here, and these angles should be equal. Why? Because they're alternating angles created by the intersecting line BP with the parallel lines AD and BC. And similarly, angle PAQ and angle BCQ, so those are marked in green. Those angles are also alternate angles, and they should be equal as well. So that makes triangles APQ and BQC similar to each other. And if we draw the altitudes of those triangles, so we can draw the altitude by dropping a perpendicular from Q to R and then extending it out so that it meets the other side BC at S. And this line, these altitudes, they will be parallel to the side AB and DC of the rectangle, right? Because it's an altitude, so it will make a 90-degree angle with the opposite sides AD and BC. And so it will be, in effect, parallel to sides AB and DC of rectangle ABCD. And since triangles APQ and BCQ are similar, the ratio of their altitudes, so RQ by QS, will be equal to ratio of their corresponding sides AP and BC. And since BC is equal to AD, ABCD being a rectangle, the opposite sides are equal. So this becomes AP by AD, and since P is the midpoint of AD, AP by AD will be equal to half. So let's denote the length of RQ by L. So that will make the length QS, the altitude of the triangle BQC, equal to 2L, because the ratio of RQ and QS is half. So if RQ is L, then QS will be equal to 2L. Let's consider the height of the rectangle AB is equal to Y, and then the width of the rectangle, let's call that X. So BC is equal to X. And that will make AP equal to X by 2, because AD will be equal to BC, and since BC is denoted by X, AD will be also X, and P being the midpoint of AD, AP will be half of AD, and since AD is X, AP will be equal to X by 2. So that's pretty simple. So now from geometry, we can write, the length of RS, the total length of RS should be equal to the length of AB, and length of AB is Y, but the length of RS is RQ plus QS. So combining the lengths of RQ and QS, we get the length of RS, right? So length of RQ is L and length of QS is 2L, so we get L plus 2L is equal to Y, from which we can have 3L equal to Y, and we can express L in terms of Y as L equal to Y by 3. So what's the area of triangle APQ? The area of triangle APQ, you know that area of triangle is half base multiplied by altitude. So the base of the triangle APQ is x by 2 and altitude is L. So the area of triangle APQ will be half multiplied by x by 2 multiplied by L. And we have already found what L is in terms of Y. So we can substitute L as Y by 3, and this comes to xy by 12. And since xy, the product of the height and the width of the rectangle, basically gives us this area. So that's xy equal to a. So xy by 12 becomes xy by 12 equal to a by 12. So if we combine the area of triangle APQ and the quadrilateral DPQC, so that's the shaded area that we have been asked to find. So if we add those two areas up, we basically get the area of triangle ADC. But what is triangle ADC? Well, its area should be half the area of the rectangle, because we know that a diagonal AC basically cuts the rectangle into two triangles of equal areas. So each of those triangles should be essentially, their area should be half that of the rectangle. So we can write the area of triangle ADC as a by 2. So we have here triangle APQ, the area of triangle APQ plus the area of quadrilateral DPQC is equal to a by 2. But we've already found out what the area of triangle APQ is in terms of a, and that was a by 12. So we can write a by 12 plus the area of quadrilateral DPQC is equal to a by 2. And from this, it's simple to solve for the area of quadrilateral DPQC, which comes to a by 2 minus a by 12, and this comes to 5a by 12. So the correct option in this case will be option D, 5a by 12.